Hello, welcome back. We are almost done. We have our 15 puzzle app. Let's go right here. Now we can highlight this or have the cursor to the right and do it. We have our numbers put into this in random order. And we have an empty cell. So now we need to make it, if I press the down key or the right key, nothing happens. We have to make it so something happens. So two things we need to do. First, let's go to the 15 puzzle application. And I'm going to add in a category here. The standard is interface opening. And I'm going to put in a method. I have it already built. And that will look like this. I'll take that one out for right now. I'm going to accept that. Now the first thing we notice is model is red. That means it doesn't understand it. So if we want to access the model, let's create a model method, and the model, the name of my model is 15 puzzle model. I could have put 15 puzzle model in there, but model, I can, if there's other applications I want to use something like this, model is a standard, and I can just have it, the model method return the right one. So what this says, this basically puts a hook in here that says, if I type in the up arrow, it sends the message, self model move up, and then it actually consumes that event. So it tells my model, move up, move left, move right, move down. So we'll need to come here to model, and let's create a new category called moves. Okay, so moves, we'll have to figure out how to do these things. Let's start with what we do if we move down. Okay, so first we have to find the empty position on the board, right? Let's open this up. We have to find out where this empty position is. So let's say self empty. I have to spell properly. Position. Okay, well, we don't have that yet, so we'll save, okay, self empty position. Let's accept that, make this a temporary variable. So how do we get our our empty position? Well, let's create an information. And one of the things I'm going to want to get is all positions. All positions, we know there's 16 positions. So let me do this. Let's say all positions is going to be an ordered collection. I could just say new and it will add, but since I know the size, I'm going to say, hey, this can hold 16 things. I'm going to do something similar to what we saw before. One, this is a keyword message, 1 to 4, do, to do. That takes a block. This is going to be the row. And then, let's see, then 1, 2, to do, 1 to 4 do, column, vertical bar. And then I'm just going to say all positions add, row, at, col. Remember the at is a binary message that we'll create a point, period. Then I'm just simply going to return all positions, except that temporary variable. Now I could actually highlight this and inspect it, and I get 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, all 16 positions in our grid. Okay, that's all positions. Now, how about empty position? Where is the empty position? Well, how do we figure out the empty position? Well, if we take all the positions, so if we say all positions gets self all positions, and then we say get my puzzle pieces, and for each one do, I'm just going to use each, EA for each, all positions, remove each position. Okay. Then the only one left, return all positions first. So I have 16 positions and I have 15 puzzle pieces. If I remove the position for every puzzle piece, there's only going to be one left, and that's going to be the empty position. So let's accept that. That's going to be the empty position. Okay, so now we've got some of the infrastructure we need to figure this out. We have the empty position, right? And it's the position above that we're going to move down into that empty position. So, well, we're going to create something else that says move from the empty position to, no, actually we're going to move into the empty position. We're going to do the empty position minus, let's see, it's x, x, y. So one row up will be minus 1 at 0. So that'll be basically empty position, the row above it, minus 1 row, 0, 0 columns, 2 empty position. Okay, now problem is we don't have move from to. Let's accept that, and let's do a move from, and we can call this from point to point, or to position, whatever we want to call it. So, which piece is at the from position? So we want to find what piece are we going to move? What is our move piece? So how do we figure that out? Well, let's say puzzle pieces. Now another type of iterator, we saw to do, that's an iterator that iterates through data collections. Puzzle pieces is a collection of puzzle pieces. There is one called detect. Now detect goes through until it finds one that meets the criteria. So I'm going to say each, detect each. It'll pass each puzzle piece into EA. Then I'm going to say each position equals from point. That'll be the piece. If it can't find any piece, just just make the move piece nil. And if the move piece is nil, if nil, just leave. Return nil. But if it is here, I'm going to change move piece's position. Remember, each puzzle piece has a position. I'm going to change that to 2 point. Okay. Let's accept that. Temporary variable. So move a puzzle piece from this point to this point. So first we find the piece that's at from point and we change its position to 2 point, right? Pretty straightforward. Well, there's one more piece. How do we get the visual to update based on this change? Well, we're going to use the changed mechanism, and we're going to say self-changed. We've changed the board. So remember we talked about the model view controller architecture. So this is the model. We've changed, say we press down, we move the 10 from here, the from position, to here, the to position. Now we want this board to basically redraw itself. So we've said the model has said, hey, I've changed the board. So the view needs to understand that through the updating mechanism. And to catch that on this side, we just need to say update. And that's going to be a symbol, because pound board is what was the symbol. We said self-changed pound board. So now we can say a symbol. Okay, there's equal, there's double equals. Equal says, are these objects equivalent? Double equal says, is this in fact the same object? And for symbols, a symbol by, for example, pound board, the system, the Smalltalk system, if you have pound board 100 different places, it's a reference to one instance of pound board. So I can use double equal, which is a more efficient way to do it. So if true, then the view understands a message called invalidate now, period. So that says if the model says, hey, move, I moved a piece, and I'm going to say, hey, the board changed, so this will receive that, and it will invalidate now. Let's open this up. Let me press down, and that worked. I pressed the down arrow, and that in fact worked. Let me press the up arrow, and oh, guess what? Move up is not understood. Okay. So it basically, here's what I can go see, right? Self-model move up. Well, let me leave that right there. So check this out. I've got this error. It says the 15 puzzle model does not understand that move up. So let's make a move up. Move up. It's going to be similar. We're going to figure that out. But let's, if I do this that says redo it, it says where from? Do I start in the block? Do I start in the block it's in or the method? The method is this whole method. Actually, I just want to redo it in the block. So self key value is up. If true, self model, I'm going to step into it, and here I am. Now, this code is incorrect, so let's fix it. The empty position, where's my empty position? Well, my empty position is three rows down and 4 over. Okay. So move down said empty position minus 1, 0. So that would be the one above it, right? So move up is going to be the one below it. So that should be plus 1, 0. let's accept this. Let's see. So the empty position, 3 at 4. The empty position, let's see what this gives us. Empty position, inspect this, 4 at 4, 4, 4, and that would be right here. Perfect, that's right. So I want to move from 4, 4 to 3, 4. Now I can step into this. It says find the piece at 4, 4. Actually, I want to go through that. So let me show you what I should have done. Let me restart from the method. And this will step over everything. So that'll go right through it. The move piece is the puzzle piece 7. Is it nil? No, it's not. Change it to 2 point, 3 at 4, and then say the board has changed. Boom! There we are. We walked through this. And we could change the code. If I change the code, I could re-accept it and redo it. And it's not, the pieces have changed, so I'm not going to do this again. But now, right now, I have down, up. I hit right. Okay, right. It doesn't understand. Move right. Let's do what we did before. Doesn't understand that. We're going to leave this open and we're going to say move right, accept it. Let's create a move left also, and actually in the move left we'll insert a breakpoint. The move right will insert a breakpoint because it's not, the code isn't correct. So we want to make sure that we stop. So let's restart in the block. And it's move right, self-model, move right, which we've implemented. So now if I step into it, now we just have to figure out what the right thing is here. So if we move this to the right, let's see, the empty position should be minus 0 because we're in the same row, and subtract 1 column. That'll be where we want to move it from. So if we're right here, this is the empty position. We want to move from this position, which is subtract same row, so 0 minus 0 rows, 0 rows, and minus 1 column. So that should be what that is. And notice to get rid of this, I can simply say remove all probes, and I can try empty position. Let's see if that works, and that works properly. So if that's move right, then move left should probably be a plus 0, 1. So let's just go ahead and say continue. And if I hit move left, okay, we stop because I put this in here. And by the way, if you wanted to do it again, this will stop once. That means it'll stop once. And if you want it to stop every time, click it again. It's infinity. 0, 1, infinity. And remove all probes. Move left should be plus 0. Same row, add 1 column. So we want to move from the empty position, same row, 1 more column to the empty position. That's what we've got right here. So let's accept that. The empty position is 3, 3. We want to move it. Move left. And in fact, that works. Okay, so let's move some things around. Okay, I can move all over, right? I can move down, I can move up, I can move right, I can move left. Okay, so I have the 15 puzzle working perfectly. So I can create a new one, random. My empty is always right down here, and then I can move. I can touch my arrow buttons down, up, left, right. I have a perfectly working 15 puzzle. And again, the goal is to put the one here, the 2 here, the 3 here, the 4, everything in order down to 15. So we'll do another screencast, and we'll talk about some ideas for that. Until next time, you now have a perfectly functional 15 puzzle app. If you have questions, problems, please send them to me, Arden Thomas, athomas@cincom.com. I hope you enjoyed this. I hope you got a good introduction into using and writing Smalltalk code and developing an actual visual application that works. The big magic of Smalltalk is being able to code. So let me put the checkpoint there. I can click on write. So I can come in here, I can check my empty position, and if it's not right, I can change the code. I can change the code here. I just added a space. I can recompile it with a click because it's incremental compilation. Then I can retest the code, look at what the results are, keep making changes, keep recompiling it. So I can see for example, see what this is. If it's not what I think it should be, I can change the code, recompile the code, retest the code until I get it right, which is one of the reasons why Smalltalk is so productive, because this is called a debugger, but it's not really a debugger. It is a live development environment, and that's what makes Smalltalk magic. It's what makes this a blast, an absolute joy to work with, because you can get things done so quickly in Smalltalk. This tight loop. Inspect the results, change the code, compile the code, execute the code, reinspect the result in just seconds per iteration until you get it right. And that's one of the joys of Smalltalk. I hope you enjoyed that. Until next time, have a great time with Cincom Smalltalk.